Hi all, this is Mr. Yeager looking at physics again in terms of optics this time. So trying to introduce the concept of optics, okay? We're going to break this up into a lot of separate videos just because if I try to do everything at once, this is going to be a very, very long video. So when we look at optics, basically what we're looking at is what's called the study of light. Okay, last unit we really were focusing on mechanical waves. Light is not a mechanical wave, sound was. So this time we're looking at the electromagnetic wave, but very, very specific situations with this electromagnetic wave. But just so you know, light itself is electromagnetic and travels as a transverse wave, if we try to make a connection to the prior unit. All right. For this unit, what you'll see is we'll basically separate it out into two situations with what we're going to do with light. One, we're going to investigate essentially what does light do when it hits a mirror, and what does it do when it hits a lens. So we're looking at two major properties of light, primarily reflection and refraction. But we actually have to do a lot of drawing. We're going to be trying to show these in terms of what are called ray diagrams, but that's for a later video. So for today, for this particular video, I'm going to be just focusing on, we're going to start looking at mirrors in terms of what light does when it reflects. We're also going to look at a little bit of how we describe the image as well. There's a lot of terminology. You really need to go back and look at the file that's labeled optics terms, because there's a lot of things to kind of follow through with this, a lot of terminology that's going to come up throughout this. You'll eventually see there's lots of nice patterns, which will hopefully make this a lot easier once you kind of understand it. So, again, I'm going to try to describe the idea of the reflection of light and the reflection on a plane mirror. I'm going to get into a little bit on number 3. Maybe at least showing you what concave and convex mirrors look like, and then obviously how the light might reflect. But we're not going to draw ray diagrams, and we're not going to describe images so much. You're going to get some of the terminology we're going to use to describe images, but we're not going to get it down to details with that yet. That'll be a separate video. So, here we go. So, first off, okay, as I already said, light is a transverse electromagnetic wave. I'm going to switch colors here. Okay, transverse electromagnetic wave. The thing is, throughout this whole unit, we're going to use what's called the ray model of light. All right? And what we basically are saying, this is going to make our life a lot easier. Obviously, we just said light travels as a transverse wave, an up and down wave. The thing is, to us, since light is traveling so fast, it looks like it's traveling in a straight line. So we will just be using arrows, straight line arrows, to represent a ray of light. Now, the thing is, you have to understand, this ray of light is actually moving up and down really fast, but since it's going so quickly, to our naked eye, it looks like it's basically traveling straight. I mean, you could do that with anything. You shine a light, it looks like it's going straight out. It's not waving up and down, traveling in that transverse form, even though down at the molecular level it is. Okay? So we're going to use what's called this ray diagram of light, straight light. Okay? So, there's going to be two major things that light will do in this unit. It's going to either reflect, which we talked about, that means bounce back, or refract, which means it will bend when it travels through a different medium. Right? So in this particular section, this video, we are going to focus on reflection, because we're going to get into mirrors soon. All right? So reflection, there's actually two types of reflection out there that happens. And I mean, this is something that you see all the time. Okay? The first type, excuse me, is called specular reflection. And what happens there, and I have a drawing on the next page, is the light rays will all reflect perfectly parallel to each other when the light bounces off. Again, you know, I'm thinking about just my projector. Think about looking at the screen. Essentially what's happening is you have multiple sources of light, there's multiple areas of light coming towards you. They hit you in all areas. What we're trying to say is they will all reflect back parallel perfectly, and this is how we're able to see an object. So it's called specular reflection. All the light rays will reflect back. This will occur when it hits a smooth surface. So this is what's happening when you look at your reflection in a mirror. Okay? The light hits you, hits the mirror, and then bounces back to you again, to your eyes. Since they're all bouncing back parallel, you can see yourself in the mirror. You will see an image created. All right, so that's specular reflection. All right, so again, this is kind of showing you the top. Specular reflection is done by mirrors. It's done by windows, so when you can see your reflection in a window. It's done by water when it's smooth, when you can see the reflection in the water. So specular reflection occurs when you can see the reflection. You can see the top, all the light comes in parallel from each other and reflects parallel, and that's because it's coming off a smooth surface and following the law of reflection. Okay? The second type out there is called diffuse. And diffuse is when the light gets all scattered. And what happens there is, therefore, it's not going to come and get focused. It's not going to be able to come to a single point for you to see. And so, therefore, in diffuse reflection, that's where you throw that rock into the water and then you don't see your reflection anymore. Obviously, like cartoons and movies have always done that, where the person looks in and then the rock comes in and you can't see them anymore. That's the idea of specular versus diffuse reflection. Okay? That's more terminology. When we start doing our ray diagrams, we are specifically looking at specular reflection because we want to see an image. Diffuse produces no image. Okay? I should say no clear image. Obviously, it might form certain colors and signs of, like, hey, something is there, but it's not clear. You're picking up pieces of it. All right. There are a lot of terms that you're going to be hearing about that will be used in the problems for this. The first one is simply what we call the object, okay? And so this is the thing that essentially is being placed in front of a mirror or a lens. We will denote this with simply an arrow, okay? And a standing up arrow. So this right here, this up and down arrow, that is your object. Usually we put a little O next to it just so you know that's the object. This right here is a ray of light. So I know that's already probably causing confusion, going, oh my gosh, so many arrows. You'll get used to it. Again, very clear procedure, very clear pattern that will develop in terms of how to produce these. So that's the object. That's what's being reflected. What the light is hitting off of. It reflects off you, hits a mirror, hits a lens, and then an image can be formed. Okay, so that's object, denoted with an arrow and an O. The image is what is created by the reflected light. Okay, so it's created by the reflected light. All right, so the incident rays basically hit us and then shoot toward the mirror. The reflected is what comes off of that. It'll also be created by the refracted light when we do lenses. All right, so it's what we would see after the light bounces off of the mirror. There are two types of images out here, and these terms always get people confused. You'll be able to clearly identify one versus the other, but I know this is definitely something that people struggle with because it just doesn't seem tangible that often. We can have two types of images. One is called a real image. All right? And it turns out you probably haven't seen too many real images. Real images are actually, an example of a real image is a mirage. Okay, a mirage, the light, a picture being basically reflected off the air molecules, the water molecules in the air. All right. What happens here? All right, and this will be much clearer when we actually start doing some ray diagrams too. It's created by what we call real converging reflected light. It'll be created by light rays that it's still the real light that's reflected off of the mirror coming back and converging together, basically intersecting. Right? Real images occur when the image is on the same side of the mirror as the object. So again, that's immediately going, what? Like, you don't look in a mirror and see yourself behind you or in front of you. That would be really weird. You see yourself in the mirror. That's because you're not seeing a real image. You're seeing what we're going to see in a moment, a virtual image. The real light hits the mirror and bounces back. That's why they basically call it real. It's based on real light, the actual light rays. Okay? Because it's created by real light, we could actually project that image onto a screen. That's the example of the mirage. The screen is the water molecules in the air. So if you drive and it looks like there's a little bit of water in the air, it almost looks like water. That's obviously the steam rising and everything like that, but that's the water molecules reflected into the air from maybe the ground or other portions of the air itself. So it can be projected onto a screen. There'll be a lot of different ways to be able to identify the image as real, obviously, if you're still confused with that. A virtual image is not created by real light. All right? This will be, for mirrors, this will be an image that appears beyond the mirror, the opposite side of the mirror. Okay? It is created by what's called sight lines. And again, this is very strange. This is basically your brain essentially predicting or interpreting where the light rays would intersect in the mirror itself, creating that image. It is an image that's created by your brain trying to interpret the light that it's seeing. All right? So it's created by imaginary sight lines. And again, we'll understand what that means when we start drawing out some of these ray diagrams. So this is what you see when you look into a mirror. Okay? You're seeing your virtual image on the opposite side of the mirror, quote unquote opposite side, in the mirror, however you want to say it. All right? And since it is not real light, it cannot be projected on a screen. You can't create the image in the mirror onto the screen because that image is not real. It's not created by real light. It's something that your brain basically is interpreting of how that light is being produced into the mirror itself, essentially. All right? That is very strange. All right? Other terms we're going to talk about object distance and image distance. Basically, this is the distance for the object to the mirror, the image to the mirror, image to the lens, object to the lens. Again, I'm going to add lenses in there because all these terms are going to be used again. So this is like an initial version of a ray diagram. Here you have your object, here you have your image. Okay? And the idea is the distance would just be how far away are the two things from the mirror. You're going to learn the y-axis will be our mirror. Okay? Object height, image height, I don't even have a definition there, but it's just how tall they are. So, I can write that. How tall, okay, are the objects and the images? Obviously, only going to have one at a time there. Okay? All right. There's a lot of stuff, obviously, on this slide. What about, this is kind of introducing what we're going to be doing in a moment, except we don't use what are called plane mirrors. We're going to use what are called concave and convex mirrors. That's because in a plane mirror, you get a very specific result. All right, but this does kind of actually get to how we're going to describe these images. So, a plane mirror is a flat mirror. That's all you need to know. So completely flat. The thing is, most mirrors are not completely flat. Almost all mirrors, even bathroom mirrors, are a little bit curved. All right. So, you stand in front of the mirror. Okay, this is you on this side. You are standing in front of the mirror. Okay, you are the object. All right. What happens is light comes in, hits you, bounces off you, goes towards the mirror, and will come straight back. Because again, law of reflection. If it hits the night at a 90-degree angle with the normal, it's going to come back 90 degrees with the normal, or 0 degrees, I guess you should say, at the normal, whatever. All right, it's going to come right back. And basically what happens is you have light rays that hit every piece of your body and come back and help you produce basically this image on the other side. This is where the light is coming together, is on the other side. Okay? So, on a plane mirror, you are always seen in the mirror, which means you are creating a virtual image on a plane mirror always. All right? These 6 things on the describing the image. This is me describing the image on the right-hand side. All right? This is how we're going to describe. When we start doing other mirrors and lenses, we only have to say 4 things, but there are 6 characteristics of an image in a plane mirror. First one is it's a virtual image. You appear inside the mirror, even though the real light bounces back. Okay, that's why it's a virtual image. It's being created by what are called these sight lines. Okay. 2, you will appear the same height. Okay, this is object height, this is image height. Okay, the object height and image height are the same. You're not going to look any taller or shorter. You're going to look the same size. All right. You're going to look the same distance. The image distance will appear just as far away as you appear in front of the mirror. All right. That's why everything looks proportional, okay? Obviously, if you step farther away from the mirror, it looks like your image is stepping farther away from the mirror. That leads us to saying that there's no magnification. This is magnification, okay? Since you're not any larger or smaller, you're the same size, there's no magnification. We will say you appear erect or upright. That just means you're not flipped over, okay? You're not looking into a mirror and your head's by your feet, okay? That's not what we're saying, like, or where your feet are on this side. Your head appears where it is, your hands appear where they are, your feet appear where they are. You're not flipped upside down, all right? Again, some of this stuff is going to be difficult to get because we're not in the classroom, but this is where there are certain images, depending on the type of mirror, you might appear upside down. And I mean, the only example I can throw at you is, have you happened to ever be in a place with a bunch of different style mirrors, whether it's a fun house or whatever it is, where you might appear like you're upside down. So, in a plane mirror, you are upright or erect. Those are the same terms, okay? You're not upside down. The only really unique thing about the plane mirror is you are inverted sideways. What that means is when you move your right hand, as you move your right hand, it'll appear the image moves their left hand. That's why we mean inverted sideways. So everything is opposite. Left and right is opposite. If you move your left leg, your image will appear to move their right leg. All right? In class, I usually play the mirror game where I get like people to stand up with a partner, and basically the idea is one person moves, the other one tries to mimic them. If they're standing right in front of each other, obviously as one moves their right hand, the other one will move their left hand. All right? That's what we mean by inverted sideways. So a plane mirror, you are always virtual, same height, same distance, no magnification, upright or erect, and inverted sideways. All right, that's all we do with a plane mirror. It's all conceptual. You just have to know those characteristics. The most likely question will be, which of the following is correct, characterization of an image in a plane mirror, or which of the following is not correct. All right, basically one of those two questions. All right. Let's go over just this one last thing, and then I'm going to quit. So, when we describe an image, let's pick a different color. When we describe an image, there's going to be 4 things we're going to have to describe, describing images. And this is for all problems in this unit. All right, and you already started seeing some of this with the plane mirror, but there's only 4 things we're going to have to describe. All right, first one, is your image real or virtual? Is your image real or virtual? And we will go over that in another video of how we can clearly do that, either through math or through drawing. 2, is your image upright or inverted? Okay, it can't be both. Again, it can't be real and virtual. It can either be upright or inverted. Hopefully those terms are pretty self-understood. Basically, upright means the image is exactly how the object is set up. Inverted, the image is upside down, is reversed compared to what the object is. Okay. The third one, it's going to be related to magnification. We will say, is your object enlarged, diminished, or same size? And again, those hopefully are self-explanatory. Enlarged, image is larger than the object. Diminished, image is smaller than the object. Same size, they're exactly the same. The 4th thing about the image that you're going to have to describe, I'm just going to write it like this. Where is it? Okay? Where is the image? Okay? And that will be, again, specific in terms of, we'll get very specific with that, when we move into ray diagrams. But these are the 4 things that you're going to have to do. Each one is related to a mathematical number, and they're also related to how you draw it, which is what we're basically getting into next. All right. I don't think there's anything else. Let's go ahead and go over this too. No, we'll skip this for the next video. I think that is it. All right. So we'll stop there, and obviously you'll just jump probably into the next one when you are ready. Thank you.